Hello. So yeah, in blockchain architecture, we have already studied about our application layer, security layer, data ledger, along with blockchain tools and libraries. Now let's start with the data management layer. We've seen where data is stored in the distributed ledger. Now let's see how the data is actually built into the blockchain. What are the components that the data has? And yeah, the data management layer is the heart of the blockchain's record keeping. Here's what happens. We have transactions. Transactions are the smallest building blocks. So consider like every action that we do in the blockchain, whether it be sending cryptocurrency, updating a smart contract, recording a shipment when it's the supply chain management, it starts as a transaction. Transaction contains all the details of what's happening, who's involved, and any relevant code. Then let's come to block creation. Transactions are collected based on specific rules. Once a block is ready, it is packaged with what? It is packaged, okay, I have a block, now I have to add data into it. What is data? The actual transaction record. Then I have to hash. Hash is what? Unique fingerprint. Timestamp. When was this created? Previous hash block hash. Why? Because this will be connected to this. Consider like small linked, small, what do we call it? A small linked list. This has the next pointer that is pointing to this block, right? So I need to know the previous block hash so that I can link this block, right? Then coming to Merkle root. Merkle root is what? Merkle root is a single hash that represents all transactions in the block. You know, in a way, it makes it easy to verify if any transaction has been tempered. How? I'll talk about that next in cryptography. So what the block hash is generated using the different algorithms we use for blocks hashing. You see it's SHA-256. It produces a fixed length output no matter what is the size of the input. So even a single character changes in the transaction, the hash it changes drastically. So if the hash changes drastically, I know something has been done into the transaction. There is some tampering with the transaction, right? The chain, because each block stores the hash of the previous one. All blocks are linked like pages in a history book that can't be edited without tearing out every page after it. So let's assume there's a book, with 100 pages. Now I cannot remove 98th page, right? Because if I remove 98th page, somebody who's reading it will know that this is 97, this is 99, where is 98? So I have to remove the 98, 99, 100, right? Then coming to the smart contracts and the transactions, in platforms like Ethereum, transactions can include code. So instead of just sending money, you can set conditions like release payment only if the goods are delivered, right? This is how you do it, right? Because you're telling them, you can also add the if clauses here, right? So I think you know what is inside a block. The block contains data. Data is what? Actual transaction. The block contains hash. Hash is what? A unique fingerprint. Timestamp. When was this block created? Previous block's hash. Merkle root. Merkle root is what? The hash for the entire transaction. And that is done using the algorithms of SHA-256. Now let's come to the programming tools. We have seen the architecture and the internal mechanics of blockchain, right? But here's the question. How do we as developers actually build it? And that is how the programming tools come in. So we have commonly used languages of C++, C, Python, Java, Ruby. We have web development tools like HTML, CSS, Node.js, and all of these. These are what, for namesake you can remember, but how and where that we're going to do further. Coming to the infrastructure layer, I believe this is the last layer, the innermost layer actually. Starting with the application layer, we percolate down to the infrastructure layer. We've talked about the layers that define what a blockchain does and how it processes data. Now let's go all the way to the bottom to the layer that physically makes it possible, the infrastructure layer. Think of this as the blockchain's foundation and plumbing. You don't always see it, right? Nowadays, we don't see how and where the plumbing is done. It's all hidden behind the walls, right? You don't always see it, but nothing is going to work without it. We're not going to live in a house that does not have plumbing. Okay, so what are the key components? Nodes, I mentioned before as well. Each participant in the network runs a node. This could be a powerful server or just a personal computer, depending on the blockchain type, depending on the transactions, how heavy they are. These nodes, they store the ledger. They validate transactions, sometimes create new blocks. Then we have some networking protocols. Everything, is done inside a network. Blockchain is a P2P network. What do I mean by P2P? It's a peer-to-peer network. Meaning what? There's no central server. I mentioned before, there's no central authority. All nodes connect directly. And communication protocols define how nodes discover each other, how the nodes exchange data, and how do they stay synchronized. Then coming to the storage system, every node needs enough store to keep what? To keep the entire ledger. You know, in the public blockchains, this can actually grow to hundreds of GBs and everything. So, because I need to have the complete ledger, you need to have the complete ledger. If anything is being appended, I need to have enough space to keep that appended block as well. Some blockchains for this reason use pruning or light nodes to reduce storage requirements. Internet and connectivity. So, without stable, secure internet connections, nodes can drop out of sync, which can affect the consensus because if my node, my ledger is not up to date with what the latest update has been made, I'm out of sync. And now this is going to affect consensus because I cannot agree on that transaction that I have no record of. Coming to supportive infrastructure, cloud services like AWS, Azure, Google Cloud can host blockchain nodes or provide APIs. Then we have security measures as well, like firewalls, intrusion detection. These help protect nodes from attack. Why does now this layer matter to us, right? Because if the infrastructure is weak, the whole blockchain is going to suffer. Slow transactions, outages, security breaches because nothing is in sync, nothing is up to date. Imagine, trying to run a Bitcoin on a dial-up connection. You remember the dial-up connections? If I'm not sure if you were the generations that you had to have the dial-up connections, the rest of the layers might be perfect, but the system will collapse because it's using, it's built upon its foundation is poor infrastructure. If the foundation is poor, no building can survive, and so would be the case with blockchain. And in a way, this is going to be an actually a disadvantage of blockchain because not everybody is going to have a good connection always. Not everybody is going to have a good PC with a good storage space always, with good computation always. So yeah, this in a way is going to be a disadvantage of blockchain as well, and that we're going to see further in the technological challenges. With this, we're good with all the layers. Here come, you can take a quick screenshot of all this. And yeah, thank you so much. Bye bye.